Hi guys, in this video we're going to look at Lab 3. So Lab 3 is similar to the other labs. It has lots of parts, but I'm going to start here at question 9. So the first few questions there's some review material. It's based on the essential synthesis C. We're not doing essential synthesis E, so you don't have to worry about that. We're just doing C. So go ahead and check out those review sheets. Will be posted later this week. Go ahead and review that first before you try the lab. So there's some like exam review stuff in there, and then there's some question and answer. You have to read a story and kind of answer some questions. But I want to start here with the data and show you how we're going to do this. So the data is talking about a research question here, where we're looking at, in this lab, we're looking at different career fields and which people who graduated in a STEM field regret their choice of major after graduation compared to non-STEM fields. So in other words, let's say you're an English major and you get out in the world and you find out that it's hard to get a job as an English major, you would regret your choice of major. If you're a STEM field, maybe you are a geology major, and you get out in the world and you find out you can't get a geology job, you would regret your major. So we want to know, do folks who graduate from college, do people regret their major more often if they are in a non-STEM field? So this is data taken from a story, and you can read all the data is given here. So you can research and reference all the stuff here. But here's just a summary, right? So this is just summarized from the articles. So the surveys were done in 2014, 2017, and 2019. So for this video, we're just going to look at the first one. We're just going to look at the 2014 data. And you can see that in STEM fields, 60 out of 250 people surveyed regretted their choice of major in the STEM field in 2014. In non-STEM fields, it was 175 out of 529. So we want to know, is this a significant difference? So is it true that, and so here's your alternative hypothesis up here, right? Is the proportion, here it is the proportion of graduates in STEM less than the proportion of graduates in non-STEM fields, so the ones who have regrets about their major? So this is kind of an interesting lab. It's a little different than sort of the heavy-duty science labs that we did on the first two labs. And it brings a lot of the ideas in the class full circle. So just to show you sort of, how this works. So there's several parts to this lab, but if you want to go back and review the first 3 slides on the first day of class from chapter 1, I actually talked about a lot of the things that were in this lab. So if you want to go back and reread that stuff, you'll see if it makes sense, right? So we started off the class talking about what kind of jobs use data. Well, STEM jobs certainly use data. And are those jobs better? Do they pay more? Are they more stable? Better career outlook, better working conditions, and that sort of thing. So let's go ahead and just jump right in. I'll show you guys how to do all this. So that's just a brief introduction to this lab. I'm just going to give you the answers to, 4 or 5 problems on the lab, and then I'll show you how to do the end of the lab. All right. So let's go down here. So there's a few questions about the parameters and the alternative hypothesis and stuff like that. I'll let you read that. But I want to start with the actual calculations here. So we're using the 2014 sample data. What's the value of the sample statistic? So you go up and you look, and we have 2 different populations, right? We have everybody who graduated in STEM in 2014, everybody who graduated in non-STEM fields from the 2014 survey. And then the sample, so here we have a 60 out of 250 and a 175 out of 529. So our sample statistic, and you got to be careful, you have to know that you're subtracting the right thing. So we want to know, is this less than this? So we want to do this minus that. So whatever happens to be the first thing, you always subtract the second thing. You're not allowed to switch them. For a confidence interval, you could switch them, but for a hypothesis test, you got to keep everything in the right order. All right, well, we just want to do 60 divided by 250 minus 175 out of 529. So this is just the difference in proportions, right? So that's question 11. We're going to round to 3 decimal places. So it's going to be negative 0.0908, and then you can round it. So when you're doing intermediate calculations, you might want to keep 4 decimal places, right? Because this first 0 here doesn't count as a significant digit, right? So you even though we're only reporting 3 decimal places, when you're doing intermediate calculations, you might want to keep a little bit more. So we're going to hold on to that number. So you'd put negative 0.091 in here, for the answer, right? Negative 0.091, right? Now, you're not going to know if you got it right or not till the end. All right, next up, what is the value of the pooled proportion? So if you've been doing the homework from 6.3, which you should do before you try this lab, landlord came by. You should have done the 6.3 homework. There's a lot of work using the pooled proportion. So remember that you have a formula on your formula sheet that you can use. But we also have the data, right? In fact, you can see the data still sitting over here. In sample 1, 60 out of 250 said that they regretted their choice of major. In the second sample, 175 out of 529. So the way the pooled proportion works is the same way that a randomization procedure works in chapter 4. You take both samples and you combine them and you look and say, what would happen if the samples came from the same population? So all you're going to do is just build a fraction. If you don't have the TI-84, you can just do a normal fraction in parentheses. It'll be fine. But if you have the TI-84, go ahead and build a fraction. So we're just going to do 60 plus 175 divided by 250 plus 529. Oops. Right? So that's the pooled proportion. Now, some of you might be thinking, hey, that's not what this says on my formula sheet. In the 6.3 video, I told you that there are 2 ways to do the pooled proportion. Only one of them appears on that official formula sheet, but I did put both of those formulas in the class notes. If you're given the number of successes in both groups, you might as well just use the number you're given. There's no reason to compute 2 separate p-hats, right? Because the pooled proportion doesn't care about the individual p-hats. So because I typed it in as a fraction, I get 235 out of 779. Not everybody's calculator will do this. So I actually, on this calculator, have to type it in again, and then I get a decimal. Don't know why it does it that way using the app, but on your calculator, should be fine. Or you can always type it in just like this. You can just type it in as like a normal arithmetic problem, right? Just as like a division problem. And it'll give it to you as a decimal. So it's up to you. If you want to type it as a stacked fraction, or if you type it in as a split fraction like this, just make sure you put your numerator and denominator in parentheses, or you're going to get the wrong answer, right? All right, so that is our pooled proportion. Now, again, we're going to be rounding to 3 decimal places here again. When you're doing intermediate calculations, maybe you want to keep a little more, so we type in 0.302, right? That's what it wants. All right, standard error. So the standard error formula, oops, I hit the wrong button here. Hold on a sec. So the standard error formula, there we go. Is the one on the formula sheet or in the class notes, right? It's that big radical the big square root with two different fractions on the inside. And so this is our pooled p hat here. So we use our pooled p hat. So we just type 0.302 times 1 minus 0.302, then the first sample size, which is 250. Then you do it again, 0.302 times 0.302. You can use the full extended number if you want. Oh, hold on, I messed up. Let me try that again. I gotta build that thing again. Because I'm not using an actual calculator here. If I mess up, I actually have to do it twice. So it's 0.302 times 1 minus 0.302 over 250 plus, and then I'm just going to do another fraction here, 0.302 times 1 minus 0.302 over 529. And again, the standard error, where are we at here? Yep, here we go. So that's question 13 here. So we're going to keep 4 decimal places here. So 0.0352. Right, so 0.0352. So I have all my answers in here, and then I'm going to use these answers to do the test statistic, right? So the test statistic is sample statistic minus the null parameter divided by the standard error, so it's a fraction. I've already computed everything else, right? My test statistic is negative 0.091. Oh, and then you can subtract 0 if you want, but you really don't have to, right? Because our null parameter is 0. And then we divide by the standard error, so 0.0352. And so your, where'd it go? Here it is. So our test statistic is negative 2.59, rounded to 2 decimal places. Then we need a p-value. So you need the alternative hypothesis to do the p-value. So for the first one anyway, the alternative hypothesis is a less than, so it's left tail. And I'm going to go ahead and do it in StatKey just to reinforce a lot of the stuff we've been doing. So we're doing a normal distribution here, right? And it's a standard normal, mean 0, standard deviation 1. And so it's a left tail, and I just have to type in my test statistic here, negative 2.59. And you get 0.005 because we want 3 decimal places, right? So here it is again, right? 0.0, make it a little bit bigger. There you go, 0.005 rounded to 3 decimal places. So it's a left tail. I typed this in rounded to 2 decimal places. Remember, the rounding on this really matters. Every problem in this lab, at least for this little bit where you're computing data from the study, has different amounts of rounding that it wants. So make sure you're following the rounding rules that are given. All right, so it's negative, I'm sorry, it's 0.0048. Right, so that's our p-value, and it says 3 decimal places, so that's 0.005. And if you want to do it on the graphing calculator, let's see how to do that, right? So we are in distributions. This is a normal distribution, so it's a normal CDF. And then we already have a big negative number in there. If you want to change it to negative 10,000, you guys saw in my last video that it doesn't matter how you type this in. I don't care what number you put there, just any big old number will do fine. And for the upper, that's going to be that negative 2.59. and just keep hitting enter, and you get, again, rounding to 3 decimal places, you get the same thing we got over here with stat key, right? So here's 0.0048, 0.004798. So very, very close, and because we're rounding to 3 decimal places, it's 0.005. So you guys have to keep going, and you have to do some more. You have to do the same sort of thing with the other data, but just follow the steps that I did here. The rounding might be different for different problems. Just keep track of the rounding. So here, the rounding here was 3, but for here it was 4. There is a little wiggle room. Make sure you're rounding properly. It's very, very important, because it might give you the right answer if you're rounding wrong, but then later on, those rounding errors are going to goof up later answers. So just because it says you got it right, there's a little bit of a tolerance on there. Make sure that you're rounding properly. Okay, so let me skip to the end here and show you what to do at the end of this thing. Okay, so the last problem here, question 28, it's called the reflection. And what it says, so I'll just go ahead and read it and we'll talk about it a little bit. So it's worth 10 points, which is a lot of points. It's a 61-point assignment. And so the idea is that choosing a good career field is important. And for those of you out there listening, you guys might be totally locked into a career path, or maybe your options are open. I've had some students tell me in recent weeks that they like statistics more than they thought they would. That happens every semester. A lot of people come in thinking, oh man, statistics is just going to be mean, median, and all this stuff. It's a lot more than that, right? We're trying to learn about stuff in the real world. And if you've learned anything in the last 40 days, it's that understanding data is one of the most important things in the whole world in today's economy. So, oh, I goofed it up. What did I do here? Oh, here it is. Okay. So, so the idea is that there's some links here, and I want you guys to click and go explore. So this first one is payscale.com. This has salaries and percent of alumni who say the work makes the world a better place. So obviously doctors and nurses would have a high percentage. Pro golfers, probably a low percentage. And then there's US News here, which I've used a bunch in this class already. And it tells you about what kind of education you need, how many projected jobs in the future, unemployment rate. I want you guys to find your career field. If the data is missing, pick something close to your career field and explore it a little bit more, right? So if you want to be like an architect, let's say you want to be a commercial architect and there's no data, maybe maybe look up something that's similar to that, like a city planner or something like that. And what you want to do is you want to write 8 to 10 grammatically correct sentences describing specific details. So essentially, you got to talk about at least 8 different things, right? The salary breakdown. Is the world made a better place by this job? And it's fine if it's not. You guys can pick any job you want. Talk about the education. Talk about, all the bullet points here listed. So one thing I would recommend to you is that you're going to be writing, it's like, 2 or 3 paragraph essay here. If you turn in just some very lame work, I'm just going to give you a 0, so don't even do that. Put the work in. You should put at least 20 minutes, 30 minutes into just this question. And I would recommend sort of typing it in like a Word document, getting it nice and formatted, and then copy and paste it in. That way, if your internet goes out or you make a mistake, you can save your work, shut everything down, and it still saves it. It's hard to save this. Now, you do get to do multiple takes on this lab, so make sure you save whatever you type in here. Make sure you save it somewhere so that if you have to resubmit it, you can just copy and paste it from that saved worksheet. so you don't have to type it in again, because you're going to put, hopefully you're going to put some work into this. And so just generally discuss, you know, using ideas from the class, using ideas from the lab, and using just your own view, you know, having been a college student doing definitely the strangest semester and anybody can remember, you know, just give some reflective looks on, you know, how your job might use data and what kind of career outlook there is for the job you pick. And that should be fun. Or you can do more than one, but I would say just pick one. And a couple things, guys, you have to like write in complete sentences. For example, I don't know, let's find, yeah, so here's my 100 best jobs, right? You guys saw that earlier. So let's follow this link. Right, so this is, you can view all majors, right? So let's pick majors, I don't know. Let's pick computer science and engineering. Wait, maybe not that one. Here we go. So this is the highest paying 2-year degrees, right? Things like that, you can see, and there's like 15 pages. Right, pretty cool stuff. Here's radiation therapy, right? That's a good one. So mid-career pay, very good. Who wouldn't want to make $93,000? 92% say that makes the world a better place. So, you know, talk about stuff like that, right? And that's how it works. So just go through, talk about, are you surprised by anything? Is it what you thought it was going to be? And so on and so forth. And then the other one is the stuff we saw earlier in the class with the U.S. News 100 Best Jobs, right? And you can read more about it. So you click on read more, and it gives you all kinds of cool breakdowns, right? Sort of what you do in that job, how many jobs are available, unemployment rate, you know, so just give me your summary thoughts and your final thoughts. And hopefully you have a, you know, a nice happy outlook moving forward, especially if you want to go into a STEM field. So that's what you got to do. That's the whole thing. And I'm going to stop the video there. So that's it for the videos, unless you guys want to see videos about referring to stuff on the final exam. Feel free to post that stuff or send it to me, and I can put together a list of problems. Alrighty, so that's it, guys. And if I end up making another video, I'll see you then. If not, I hope you guys had fun this semester. And let me know if you have any questions. Bye-bye.